Aditya L1, the first space-based Indian mission, is set to revolutionize our understanding of the Sun. Placed in a strategic halo orbit around the LaGrange Point L5 of the solar system, this spacecraft will have an unprecedented advantage, an uninterrupted view of the Sun, 24/7, without any eclipses or occultation. On the auspicious occasion of Indian Independence Day, we bring you the story of Aditya L1's mission, scheduled to launch on August 26, 2023. But the question arises, what is the purpose of the mission? Why is ISRO so keen to study Sun? You know, the Sun is like our cosmic neighbor, hanging out right next door in space. And you won't believe how much we can learn from this fiery giant. We're talking about stars here, not the movie kind. See, studying the Sun is like getting a sneak peek into the secret lives of stars in our Milky Way and even galaxies far, far away. Now, the Sun isn't just a big glowing ball in the sky. It's like a star with a whole lot of personality. It's got these wild eruptions and energy bursts that could put fireworks to shame. And get this, all that energy can mess with our tech stuff, like satellites and communication systems. Imagine getting a heads up before your Wi-Fi crashes. That's why understanding these solar explosions is a big deal. Oh, and here's a twist. If an astronaut ever gets caught in the line of fire of one of these solar tantrums, it's not a good day. So, knowing when these space fireworks are about to happen is crucial to keeping our astronauts safe. You know, the Sun is always busy interacting with our Earth, sending out radiation, heat, and a constant stream of particles along with magnetic fields. This stream of particles, like a solar breeze, is actually called the solar wind. And guess what? These winds are mostly made up of supercharged protons. It's like the Sun is blowing a never-ending bubble of energy around our whole solar system. But that's not all. The Sun is also a master of magnets. Its magnetic fields, along with the solar wind, spread out throughout our solar neighborhood. Now, when the solar wind gets a bit feisty, and there's a solar event like a coronal mass ejection, things get even more interesting. During these events, the magnetic and particle environment around a planet, like Earth, can totally change. It's like a cosmic makeover. Speaking of Earth, these space shenanigans can mess with our planet's magnetic field. You see, when the Earth's magnetic field and the magnetic field carried by a coronal mass ejection get cozy, it can stir up a magnetic storm right here. And you know what that means, a little turbulence for space gadgets and gizmos. Now let's talk space weather. Yep, it's a thing. It's all about how the environment in space near Earth, and even other planets, keeps changing. As we get all fancy with technology in space, understanding this space weather jazz becomes seriously important. Plus, when we figure out what's going on near our home planet, it's like getting a sneak peek into how space weather behaves everywhere else in our cosmic neighborhood. Aditya L1 marks India's pioneering solar mission. Imagine a spacecraft cruising in a special orbit, about 1.5 million kilometers away from our planet, precisely stationed at a point where it continuously captures the Sun's unfiltered radiance, unhindered by eclipses or interruptions. This unique vantage point is known as LaGrange Point L5 or L1. What makes this mission even more exciting is that Aditya L1 carries an impressive array of 7 distinct tools or payloads to scrutinize various aspects of the Sun. These include keen observations of the photosphere, the chromosphere, and even the Sun's outer layers, corona, using a mix of electromagnetic and particle detectors. Detailed video covering the various payloads and their purpose will be uploaded in a couple of days. Make sure to subscribe and hit the notification bell to never miss important updates. Moving on. From understanding coronal heating to predicting coronal mass ejections, and from decoding pre-flare and flare activities to unraveling the complexities of space weather, this mission holds the potential to unlock the mysteries of the Sun's behavior and its impact on our solar system. Is this a complete mission to study the Sun? Well, the simple answer here is a big no. This holds true for pretty much any space mission out there. You see, space missions have their hands tied due to limited mass, power, and space on board the spacecraft. This means they can only carry a specific set of instruments, and that too with some serious limitations. In the case of Aditya L1, it's all about taking measurements from the LaGrange Point L1, which is quite a feat. Take the Sun, for example. It's a bustling hub of activity in all directions, making it quite the challenge to capture the full energy distribution of its explosive events from just one vantage point like Aditya L1. But guess what? There's another LaGrange point called L5 which could be a goldmine for studying those sun-directed CME events and getting a grip on space weather. Interestingly, even the Sun's polar regions have remained somewhat of a mystery, mainly because it's tough to get spacecraft into the right orbits for such observations. And trust me, understanding the dynamics and magnetic fields in these regions is a big deal. They're like the maestros behind the Sun's performance in its various cycles. But there's more. To truly get the whole picture, we need polarization measurements of solar radiation at different wavelengths. These measurements are like puzzle pieces that help us solve the bigger mystery of the processes that go on in and around our fiery star. So, while Aditya L1 is set to teach us a lot, there's a universe of stuff out there that's yet to be fully uncovered. Click here to know what else ISRO is up to. Make sure to subscribe to never miss an update.